Hey geometries, this is Mr. Bloom, and today we're looking at lesson 8.1, the Pythagorean Theorem in its converse. Okay, our objectives in this lesson is students will be able to use the Pythagorean Theorem in its converse. Please write that down. When I check notes, I am looking for the objectives. People are skipping them. They're missing a point here and there because they don't have it. So stop it and write it down. Now, our essential understanding, if you know the lengths of any two sides of a right triangle, please keep this in mind, this only works for right triangles, you can find the length of the third side by using the Pythagorean theorem. Okay, so here it is, the Pythagorean theorem. You've seen this before, we used it quite a lot during first semester. If a triangle is a right triangle, then the sum of the squares of the lengths of the legs, the sum of the squares of the lengths of these two legs, their sum, if I square them separately, okay, equal the square of the length of the hypotenuse, equals the square of the length of the hypotenuse, and that's what this is. This is, if I know it's a right triangle, I can use this to find any one of the three sides if I have been given two of the three. All right, let's see how we use this. So, finding the length of the hypotenuse. What are the lengths of the hypotenuse in the triangles below? So I have two legs, okay? I've got my two legs, all right? So let's check those out. So we got our two legs. Let's put my arrow over the side, and my Pythagorean theorem, a squared plus b squared equals c squared. Now I'm going to plop in that I have 21 squared plus 20 squared. And I could have done that any order, okay? My 21 squared, okay, if I go over to my calculator, you got 21 squared, squared, okay, that's 441. Okay, so I got 441 plus 20 squared, and that's 2 times 2, which is 4, and 2 zeros, so it's 400. Okay, so now I've got 841 in my calculator. So I'm going to add 20 squared, and that's going to give me my 400 more. So I got 841. I'm going to take their square root. There's two ways I can do the square root in a calculator. The first one I'm going to do is a fractional square root. You'd probably have seen it in the Expo, but if I raise my answer, and when that does that, this answer is right there, 841. Now I'm raised that to the 1 divided by 2 power. That is a square root, and I get 29. I could use my calculator buttons, and I could hit the fact that I got 841, okay? And I'm gonna, we're gonna do the square root of 841, so I gotta go the square root of 841, all right? And then we'll arrow out and get rid of this other stuff. So I've got the square root of 841, and I've got my value of 29. So here, as I continue on, I have c squared, and I've got 841, and this is how you show your work, and that'll be 29. So this is 29 units, whatever that would be. It is now your turn to show your work the same way as I just did. So over here, get after it. And now we do have a letter C here, but C is playing, it's masquerading as a leg. It is not the C in your Pythagorean theorem. So before you even start, let's just call this B for fun to start and get going. So go ahead, turn me off and give it a try. Okay, welcome back. We've got, again, Pythagorean theorem. Every time you use it, you write it down. You will memorize it that way. Now, I've got 8 squared plus b squared is equal to 20 squared. So now I am not just looking for a hypotenuse, I'm looking for one of the legs. So I have 64 plus b squared, that's 8 times 8 by the way. And I just did that 20, which is 400. Okay, now I'm going to subtract 64. So I'm over here, I'm on my calculator, I got 400. I'm going to subtract 64, and I get 336. So I have b squared is equal to 336. Okay, now I've got to take the square root of both sides. Now what happens if I do that in my calculator? If I take the square root of 336, is that a perfect square? Ooh, it isn't a perfect square. It's kind of ugly. But 336 has 3 that goes into it. 336 divided by 3 is equal to 112. All right, so I'm going to do a factor tree here. So I've got 336 divided by 3 is 112. 112 divided by 2 is 61. Excuse me, 51. I apologize. So I got a 51. Okay, now 51 divided by 3 is 17. So I got 2 3s. You see those? So that's 9 times 2 times 17. So my B is equal to the square root of 9, perfect square, times 34. So I've got 3, the square root of 34 for my solution. And remember, we changed that B to help us to be from a C. So really here, the variable C is 3 the square root of 34. Now, looking on, this is your quiz, no picture. Do you got it? Turn me off and go. Now, the legs, if I look at the legs of a right triangle, have lengths 10 and 24. These are leg values, A and B. I don't care which one you plug it in for. What is the length of the hypotenuse? Okay, so I have legs, so I'm going to take my legs and my equation with the Pythagorean theorem. One of them's 10, the other one's 24, and I'm going to find C. Now, again, I'm here, I've got 10 squared, okay, and then I got plus 24 squared. Now, I know 24 squared is 576, okay? And I've always got people going, well, how do you know 24 squared is 576? Because that's what it is. So I've got 10 squared, which is 100, plus 576 for 24 squared, and that's C. And I'm going to take the square root of that, which is the square root of 676 equals C. Okay, now 676, okay, so if I take the square root, second square root of 676, and hit enter, that is actually 26. So that's pretty darn nice. It's a perfect square. Okay, now that's C, but now they're saying what's the length of the hypotenuse? And I've got to say the hypotenuse has a length of 26 units. Word question, word answer. Okay, and I have my work to support that. Now let's slide on. Now, finding the length of a leg. Oh gosh, we did the length of a leg in the original example. So this one you're going to do on your own. Turn me off and try it. Go. Okay, welcome back. All right, so now I have A squared plus B squared equals C squared. That's what I'm plopping in. That's what I got to get going on. I am looking for a leg. Now, some people are like, well, how do you know it's a leg? Legs make my right angle. The hypotenuse is always opposite the right angle. That's how I check. So now I'm going to pop these things in. I've got 11 for my A. I got B squared I'm looking for, and C is 25. Okay, 11 squared is 121. B squared is equal to 625. So I'm going to take my 625, just like you guys would. 625, subtract 121. Okay, and I got 504. Now, so right now I'm sitting at B squared is equal to 504. Now, they want me in simplest radical form, so I got to reduce. Okay, and 504, boy, you know, if I add all the digits, I can find out that it goes into 3, but since it's even, I'm going to check out a factor tree real quick. So 504 divided by 2 is going to be 252. Okay, and if I divide that by 2, okay, and let's do this over here so you guys don't have to like try to do that. I got 504 divided by 2. Okay, now I'm going to divide that by 2 because it's even, so I get 126. I'm going to divide that by 2. Divide that by 2, and I get 63. Now, I know 63 is 7 times 9, so I'm going to go 7 and 9, and that's 3 times 3. I'm just going to hit 9 because that's perfect square. I got a perfect square in those two, and I got that perfect square. So now I know if I was going to take the square root of both sides here, b would be 4 times 9, which is 36. That's a perfect square times 14. Now we're going to check this just to make sure I'm not wrong. Okay, I got 36 times 14, and that is 504. So 36 is the largest perfect square factor of 504. So I have, as my answer, 6, the square root of 14. Six, the square root of 14 is my length of my leg. Now, finding distance. Dog agility course often contains a seesaw obstacle. Well, let's get my pointer here so we can talk about it. Okay, dog agility course. Okay, course often contains a seesaw obstacle as shown below. To the nearest inch, notice what they're saying, nearest inch, how far above the ground are the dog's paws when the seesaw is parallel to the ground? So if the seesaw is parallel to the ground, it's here. And that would be the height of the fulcrum here. So we're going to find this length based on these measures. They give us a leg, they give us a hypotenuse. Okay, you've got to find this, the other leg. Okay, ready, set, turn me off, and go find it. Go. Okay, welcome back. We have a squared plus b squared equals c squared, where I have an a, 26, or b, say. A, I'm looking for. B is, and I'm going to call that height because they want a height above the ground. H, okay, 26 squared is equal to c squared, which is 36 squared. Okay, so again, I've got 26 squared, and that's 676. 676 is equal to, and I got 36 squared, 36 squared, and that's 1296. And I've got to find my h. So I'm going to subtract those, and h squared is going to be equal to 1296 minus 676. So I got 1296 minus 676, and that's going to equal 620. So that is equal to 620. Now, here's the thing about this. They ask in the directions, okay, as shown below, to the nearest inch. Okay, so I can just take the square root of this with my calculator and I'll be okay. So h, the height, is the 620. So I've got to go the square root of 620. So the square root of 620 equals 24.899. Okay, this becomes 24.899. But to the nearest inch, it becomes 25. So about 25 inches. How high will the dog's paws be? The dog's paws will be about 25 inches above the ground. When our board is parallel, when the seesaw is parallel, when seesaw is parallel. Okay, word question, word answer, and we have supportive evidence for our work for the grader to know, oh, that's where you found it. Okay, now we got something called Pythagorean triples here. A Pythagorean triple is a set of non-zero whole numbers. Whole numbers are the numbers you learned about in kindergarten, a, b, and c, that satisfy the equation a squared plus b squared equals c squared. Now, keeping in mind, this is an example, so is this, so is this, so is this, of Pythagorean triples. This is 9 plus 16 equal 25. Remember, I'm squaring them. 25 plus 144, excuse me, 144 is equal to 169. Okay, 64 plus 225 is going to be 289, and that's 17 squared. And then I've got 49 plus 576 is equal to 625. 625. Okay, and somebody's got to be able to put that around a little bit better so you can see it. So I got 625. So those are all examples of Pythagorean triples. Okay, these are values that work in the Pythagorean theorem. Now, keeping in mind, we're going to fill in the missing values for each of these Pythagorean triples. They may or may not match with these, but if you multiply any one number in a Pythagorean triple, you multiply all the numbers in the Pythagorean triple by any number you want, okay, multiply them by the same whole number, the result is a new Pythagorean triple. So 3, 4, 5, 6, 8, 10. If I multiply by 10, 30, 40, 50, Pythagorean triples. So if we're looking at fill in the missing values, we're going to be on our way to checking it out. So remember, this is a squared plus b squared equals c squared. So 9 squared plus 40 squared is equal to something squared. Okay, so I got 9 squared plus 40 squared equals 1681, they say. Okay, so this comes out to be 1681. Maybe I should say it this way. Make it better. That'll be c squared. And this is 1681. And so if I find c, find their square root, I have the square root of 1681. Has to be 41. Okay, so I have 41 is equal to c. So this will be 41. Now, it's your turn. Go ahead and do the next ones. Okay, turn me off, then turn it back on and to check your work. Now, a squared plus b squared equals c squared. 11 squared plus 60 squared equals c squared. So we got 11 squared and 60 squared. So I got 11 squared plus 60 squared equals 3721. And let's try to square root. 0.5, 61. So 11 squared plus 60 squared. I got to get those numbers in there. I want to make sure we have it. 3721. I'm going to find the square root of that, and that is 61. Okay, our next one was 6, 8, and 10. And if I go 6 squared plus 8 squared is equal to c squared, this is 36 plus 64, which equals c if I take the square root. And that's the square root of 100, by the way. So 10 is equal to c. My last one, well, I got 2 left. 100, or 10 squared plus 24 squared. Now, we already did this one, c squared. And this is 100 plus 576 is equal to c if I take the square root, and that's the square root of 676. And in case you forgot, that is 26 squared. So if we erase what I've got on my calculator here, and we go, hey, I'm going to take the square root of 676 and hit enter, and that's 26. Bloom was right. He's got a memory. Okay, 26 is equal to c. That is 26. And our last one here in this group, oh, that was the last one in our group. Gosh, that's it. Okay, so that's it. You got today's assignment. You're doing exactly what we just did. Good luck with it. And again, if you have questions, please seek out assistance from your local geometry teacher. And as always, I hope you have a great day. And again, my name is Mr. Bloom, and you're not.